So here we got 5 switches, and switch 1 has got the lowest priority. Switch 2, 3, 4, and 5 has got same priority. And let's say the MAC address of this switch is A. This one is BBB. Assume this as the bridge ID or the MAC address switch ID. Now, let us give some name for this interface. Fast Ethernet 0/1. Fast Ethernet 0/2. Fast Ethernet 0/1. Fast Ethernet 0/1. Fast Ethernet 0/2. Okay, these are all the interface names. Now you need to tell me where all forwarding will be and where all blocking will be.
Yeah. Yes.
Let's start from switch 1. Tell me switch 1 F01 what will be, switch 1 F02 what it will be.
So first of all, we need to identify the root switch in this network. So root switch is based on the MAC address. So MAC address is A, B, C.
No. Why are you doing like this? After one or two spanning tree class, you cannot say like this. First, it will compare the priority. Why it will go to MAC address?
Okay. Sorry. Yeah, priority is equal to 0, 52768. Okay, all are okay. Then yeah,
All are 32768.
So priority 0 will be the first. That will be the root switch.
Okay, let me write down. Root switch.
F01, F02 will be forwarding because the root switch is because
designated to forward. Okay. Next.
Next is switch 2. Switch 2 will be that will be the root port F01 of switch 2 will be root because
Why?
it is going to the root switch through F01.
We can also go like this.
But the cost is more, right?
Correct. That is what I was asking. Why? Okay, cost is more, so it won't go like this. F01, as you said, it's a root port. Root port will also
Forwarding, yes.
Forward only. Okay.
And F02.
Let us not go there. Let us go to switch 3 now.
F01, it will be forwarding. Root port, yeah, forwarding.
Root port, forwarding. Okay, now go to switch 4, then you can come here. First you finish switch 4, then you come
switch
here.
4, F01 will be the forwarding because, I mean,
root port. Very good.
Forwarding.
Root port, forwarding. Every switch should have a root port. Okay,
port,
so
forwarding.
here also root port, forwarding. If this need to forward, this cannot block, right? This will be designated forward. Because this is not taking you to the root switch, it is taking to the down switch, so it is designated. Yeah, see, this is also going downward, that's why it is designated. You got it? So this is also designated to forward. Okay.
F02 of 5 and F02 of 4, they will be blocked.
Yeah. How can two port block? Any one only should block.
F02. So we'll check the incoming of F.
No. Incoming and all, when only when you have two links, this is incoming lower or this is incoming lower. When you have only one link,
MAC,
you don't
then
have
we have to
incoming and
consider MAC is lower for switch 4, so it will be active forwarding, yes.
correct.
Block.
So this is going to be BLK alternate, and this is
Forwarding.
designated forwarding.
Yes.
That's all. All right. Later you can check this in your lab. Okay. Now let us go to another level, and let us assume that I change the priority here to let's say 4096. Now what will be the role of all the ports? Tell me.
Role of the
All the ports. What will be the role of all the ports and all the switches?
So first, I mean, switch 1, it's a priority 0, so it will be the root switch. And port of switch 1, both ports will be designated forwarding. Yeah.
To forward. So there is no change in that, right? Okay.
Now switch 2, F01 will be the designated forwarding to the root switch, so it will be the root port. And similarly, switch 3, F01 is the root port and it's in forwarding. Now switch 4, F0, switch 4 to, yeah, correct one. I mean, from switch 4, F01 will be designated forwarding. And for switch 5, F01 will be designated forwarding. And for switch 2, F02 will be designated forwarding, and switch 3, F02 is designated forwarding. Switch 2.
Repeat again.
Yeah, yes.
Okay, this one you're talking. Forwarding.
Now 4 and 5, F02 will be F02 will be the active link because MAC is less, and F025 will be the blocked.
You see, if this goes blocking, what will happen, you know? If something goes wrong with this switch, when this becomes a root switch, correct, no? Next smallest is this. This will become a root switch. Then it will be a lot of learning. So what actually does, you know, that is what I want to teach you. Earlier, this priority or this priority was same. So this way, this path and this path was seen equal. But now for this path, more weightage because of less priority here. So switch 5 will not
root
block.
Switch is still active, no? Okay.
See, the root switch is still active. I am repeating again. Root switch is still active. Now, switch 4, you know, earlier this priority was same. The time switch 4 is comparing the upstream neighbor's priority. Switch 5 is also comparing. There is a tie.
Yeah.
So 4 and 5 was comparing only the MAC address. And it was blocking here. But the story is not the same now. Now, via 3, this guy has got more weightage because the priority is low than this one. So this port will not block, this will block. This will be designated forwarding. Why you know? So that if something goes wrong with this,
so
this is still forwarding. You don't need to unblock.
Okay,
Majority
understood.
of this,
So basically,
only this will get unblocked.
Since the switch 3's priority is 4096, switch 5 is deciding to go through switch 3, right? In case any anything happen on root switch, right? So
Yeah. That's why now itself it takes a decision not to block on switch 5 side, but to block on switch 4 side. Now let's have another scenario. Let's say the priority is 4096 there. I don't want to change that. Let it be 4096. But here, this is gig Ethernet. This is gig 0/2, gig 0/1. Here it is same fast Ethernet. Yeah. And here also it is same fast Ethernet. Now what will be the port rules? R1 is still active. R1 is still
so
root
basically
switch. So
from
switch 1 is
5 point of view,
still root switch.
It can either reach via switch 4 to 1 like that, or 5 3 1. So if it's going through, yeah.
Wait, let's see that. No, it is not like that. For switch 5, what is the cost? 19, 1, sorry, not 1, it is 4, no? 4, 19, and 19. See, this will say, I'll go this way because it is only 19. This will say, I'll go this way because it is 19 plus 4, 23. If I go this way, it is 3 19s, too costly. I won't go this way. Okay. Now for switch, for switch 5, if it goes like this, it is 19 plus 19. If it goes like this, it is more than that. 19 plus 19 plus 4. So even now, the role change is not going to vary. We have to do this and see.
So what we are going to
you
do?
You want to do it later, or you want me to do on show?
Okay, sure.
What we have spoken now, we need to test.
Yeah, could you please test and show?
You want to test it later, or you want me to show test and show? Okay, it's in the recording. So we got this topology, and when you compare the MAC address, you can see this is the lowest MAC address. See, 000. And 2.
Priority
here also 000, but it is 10. A is 10.
Yeah.
So the.
Yeah, correct.
No, we have not changed it yet. This is as of now default. Okay. Now, I want this switch to be the root switch. For that, I'm going to change the priority so that I can rearrange the topology like this. All right. So if this becomes root switch, the blocking will be somewhere between these two switches, isn't it? Let us see. See, right now this is blocking. Let me name this switch first. I don't want 0. Switch A. So I change the host name using using the GUI. The name of the switch is switch A. Likewise, this one I would like to change the switch B. We got the name change. Now, according to our plan, we are planning to make this priority 0 here, right? So let's see how to do it. See that only VLAN currently we have is VLAN 1. Yeah? Only VLAN we have is VLAN 1. If you have more VLANs, then you need to do for every VLAN. I'm having only one VLAN, so I'm going to say spanning tree for VLAN 1. Priority. Pay attention, something very important. It says you can have any number between 0 to 61440, but
why?
You cannot have like priority 100, priority 200.
Okay.
It is only in the increment of 4096.
4096.
What does that mean? You can have 0 or 4096 or increment of 4096 like 8192. Why? You should ask why. Okay, anyway, I change the priority now. I'll tell you why it is only increment of 4096 in few minutes. Let us first focus on what we want to check. The priority is changed.
Yeah.
If the priority is changed, we are expecting the block from here to shift to somewhere here.
Yes.
Yeah, we want the block to shift. You see, it's shifting here. Now, it has shift here. Now this will also turn green. Because this is the root switch now. It cannot block. See, it's doing conversation. They're talking. Oh, look at this. It's green now. Now, why is this blocking? Because the MAC address here is bigger.
Yes.
Here it is, D and E. Now, let us go and change the priority as we discussed. Let us go and change the priority to 4096 here.
Yeah.
And we want to see whether any change will happen. Yeah?
So, which one is
we want to see whether any
4096
changes
now?
will happen to this blocking. That's our aim.
Okay. Okay.
Right now, no 4096. I'm planning to change this switch C to 4096. Let's do it.
Yeah.
Wait, let me remind you what I am doing. We change this priority to 0. After changing that, This has become root switch, even though the MAC address is bigger than switch C. If you want, you can check it. Show spanning tree. You see, this is the root because of the priority. Now we are planning to change the priority, this one, to 4096. Currently it is 32768. Show spanning tree. Currently it is 32768. Let's change it to 4096. Spanning tree priority, spanning tree for VLAN 1 priority. You see, I'm giving 100. You see what happens? It says no. It says no. Use any one of this. So I'm saying 4096. Now we want to see whether any change will happen here. Show spanning tree. Still blocking only. Sorry, no change. Okay.
Yeah,
so what I said, you forget. No change.
Yeah,
no change.
Because of cost. Yeah.
But if we change the link, it will definitely make cost because of cost. Okay, let me do that one. That one, what I said is correct. But this one, I think I brought some other concept here. Okay, now let us change the link here to gig Ethernet. Yeah. Now this is going to make some change because the cost is low here. Will there be any change? No. Because this is 19. This is 4. This 19. Is 19. Why will E change? There won't be any change. Sorry. Even now it won't be any change.
Yes.
19 for this link.
Cost is high, right? So it won't go through.
4 for this link.
For E.
19 again for this link. No use.
Yes.
Yeah. Yes. If I change this one, then there will be a change. Let's change this one. Definitely there will be a change. Blocking will happen somewhere here. Let's see. Now, E will go through this path because 19 plus 4 plus 4 is cheaper. So this will become a root port. This is going to be a blocking port. F01 will be a blocking port. Let's see. Show spanning tree. Yeah. F01 has become blocking. Earlier F01 was a root port. Yeah. But now that has become a blocking port. Because the cost on the other path is cheaper.
Sure.
So the block is switched here. Okay. This type of exercise you can do by yourself later. Now, with this, sometime you will see question in exam. Some people may draw a diagram like this and they may ask you the port roles in interview. Now let us move on to the next level. You see, spanning tree is good. It prevents loop, but it is slow. It is slow. What it will do, it will move from blocking to forward only after 50 seconds. If there is any change, For example, if I cut this wire here, the switch traffic now should go this way, isn't it?
Yes.
It should go via switch E. But to
So why
unblock, it will take 50 seconds. I want to show you that. Before that, let me explain you. Why 50 seconds? Why 50 seconds? It is going to wait for 20 seconds. Who? This E will be waiting for 20 seconds for BPDU to come from this part.
No.
Will the BPDU come? It won't come because the link is gone. If the link is gone, will this switch send any BPDU? No.
Yes, yes.
So the switch D cannot forward any BPDU from switch B because the link is broken. So switch D will not tell anything about B. So this guy will be waiting for 20 seconds. And then it will say, okay, because that guy did not give me BPDU of switch B, I'm going to move to listening state for 15 seconds. What am I going to listen? I'm going to listen for the new topology change. I'm going to understand the new change, new topology now. There is something changed because there is no BPD coming from one particular guy with whom I used to talk before. I used to talk before with that switch B, but now this guy is not talking to me. So some changes has happened. So we need to now rearrange the database according to the change. So I'm going to listen. So it's going to listen for the topology change notification for 15 seconds. And another 15 seconds, it will learn. And then only it moves to the forwarding state. 50 seconds it's going to take. Let us see now. Are you ready? Now you see. First, let me go to switch E. And I'm showing you. This is blocking. Now I'm going to cut the wire. This wire. Shall I? Okay, done. Now you see, still blocking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. See, listen. You see? Hey, listen. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You see? 15 second learning. 1, 2, okay. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You see? It takes 50 seconds totally, no? To make it as forwarding. Very slow. In a large network, this is not acceptable. See, if internet connection goes down for 50 seconds, will the conference that was going on will be able to continue when it comes back? Not possible. Session will get terminated, right? Say you are doing some audio conference, and 50 seconds if something goes down in network, what will happen? Conference will be cancelled. Client will cancel it and go. Not at all acceptable. So there is another version of spanning tree which is called rapid.
Right. Maybe the delay is very less.
Rapid spanning tree.
Yeah.
What is rapid? Yeah, fast. Rapid means fast. This rapid spanning tree is according to the IEEE standard 802.1, sorry, yeah, 1 W standard. The normal spanning tree that which we just now learned is IEEE 802.1D standard. Okay. Normal,
Yeah.
the slow spanning tree, no? This one which we are,
1W.
which we saw now, which is this standard. Rapid spanning tree is 1W. There is one more spanning tree called MST, multiple VLAN per spanning tree, MST, which is IEEE 802.1. Yes.
Yeah, sure.
1S. This is
MST
yes.
means multi. I mean multi.
Yeah.
Perfect.
Shall we check? Let us check in the Google. Multiple VLAN per spanning tree, but not many people will say what I am saying. Many people will say MST, multiple VLAN spanning tree. That's what they will say. It is multiple VLAN per spanning tree. Okay, now let us go and check. I took you and showed you that I took one W is rapid and 1S is MST. The reason why I'm saying this is also another way to call this protocol. Sometimes they will ask you, do you know IEEE 802.1S? Do you know MST? They won't say, they won't ask MST. They'll say, do you know IEEE 802.1S? That is tricky question. They're asking like this.
Yeah.
I know.
MST.
That's why I tell you this one. I insist you to know this. W means rapid. S means MST. D is classic spanning tree. Okay. Now next is we're going to see these protocols, these spanning trees in coming days. We already saw one. We are going to see rapid and MST in coming days. Means tomorrow. Now what I want to explain you now is why is the priority incrementing by 4096?
Yes.
I said priority can be 0. Next is 4096, an increment of 4096, isn't it? We saw that, right? Why it is like this? See, there are 16 bits in the .1Q header. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. In that 16 bit, up to here, you know, up to here it is for VLAN.
12, yeah.
Oh, how many bits for VLAN you tell me?
96, yeah.
12 bits. 2 to the power of 12, which is 4096. 96. Actually, because you are starting from 2 to the power of 0, then it is 4095 when you count, okay? So this is 2 to the power of, so 2 to the power of 12 bit is here.
Yes.
VLAN is only 2 to the power of 11 because you are starting from 0, 12 bits, no? So up to 2 to the power of 11 only, which will be 4095. Now, from 2 to the power of 12 onwards, it is given for priority. Okay. Now, you see how many bits are for priority? Only 4 bits. In that 4 bit, by default, This is on.
Okay, sorry.
And these
3278.
are
Yeah.
off. That is why the default priority is huh? See, what is this value? 2 to the power of 15. Calculator.
$15. Yeah.
For some reason, my computer is very slow. 2 to the power of 15, right?
Yes, yes.
Oh no. 2 to the power of
Yes.
15. See? 32768. You understood why it is by default 32768? Because this
Zero.
bit is on. Now, if you want to
Yes.
put all the bits 0,
Yes.
what is the value? 0.
2 raised to 12.
And if you want to put the minimum, you will put 1
4096.
here, right?
Yeah.
Minimum. 1 here. Then what will be the value?
Yes.
4096. And next, if you want to put next minimum,
192.
then you will put 1 here and 0 here, isn't it? That will be double of this one, which will be 8192. If you put 1 here, this plus 4096. It is increment of
Yes, yes.
4096 because from here only you are giving for
Increment.
subnetting.
Yes.
Sorry, for priority. You have done this in subnetting, you remember? From wherever the bit you give, that value only increment, isn't it? This is the reason why the priority increments by 4096. See, this is also a very important question. Why priority increments by 4096? The reason is, out of 16-bit in layer 2, which is given for VLAN and spanning tree, 12-bit is for VLAN, 0 to 11, 2 to the power of 0 to 2 to the power of 11 is for VLAN. From 12 to 2 to the power of 15 is for the priority. When all the bits are 0, then you get 0. When you have the minimum bit 1, then you get 4096. And by default, 2 to the power of 15 is on and all the rest are 0.
Yeah.
That's why you get 32768 by default.
4096. Yes.
Clear, no? The reason why priority increments by 4096. Okay, so we'll